Hey, hello, welcome. We are in Algebra 1. We're in the third learning target, and today we're going to work on slightly more complicated equations, what we call equations with the distributive property and collecting like terms. Alright, so we've got our first example here. As you know, I prefer to rewrite the equation. Just gives me a feeling of control, but not mandatory. Now here we have 9x plus x. Now the x, you might say, what's that all about? And it's really 1x, so I kind of highlighted it there a little bit for you. Now 9x and 1x can go together because they're like terms, and that creates 10x, because, well, 9 and 1 is 10. So we got 10x minus 7 equals 13. From here, it's kind of review. We're going to add 7 to each side. And then we have 10x pretty much equals 20. Then divide both sides by 10. And by 10, x equals 2. That's it. Alright, that was the first example, the easiest. Here's our second example. There's a couple different ways of doing this. As you know, I like to start by rewriting the exercise, but that's not the big deal here. For this one, I'm going to show the distributive property, or what I like to call the double rainbow. The 2 will distribute and multiply by 4x and by 3. So 2 times 4x is 8x, 2 times 3 is 6. So 8x plus 6 equals negative 8. And from here, it should look kind of silly. You got to subtract 6 on each side. Bye-bye 6. So 8x equals negative 14. And then if you divide each side by 8, by 8s, x equals negative 7 over 4. Now, negative 7 over 4 is, correct, and the best answer, I would say. But if you want to write negative 1.75, or perhaps you want to write negative 1 3/4, those are all okay. The improper fraction, I'd say, is best. The decimal is second best. The danger with decimals is if the decimal doesn't terminate, if it doesn't end, it's tricky to get the bar over the right numbers. And then the mixed number I really do consider to be the third best, but they're all correct in this case. Okay, third example. Here we have 2/3 times x plus 4 equals 8. So go ahead and rewrite the equation. Not absolutely mandatory, but it gives me an illusion of control. Now we'll go ahead and you could totally take that 2/3 and distribute it. Kind of create some extra fractions in here, and there's a simple way around this. So I want to show you this way around it. If you don't care for it, not mandatory, you can totally distribute the 2/3. But you could instead multiply by the reciprocal. If you multiply by the reciprocal, which is 3/2, then the 3's and the 2's cancel and go bye-bye, and you just have x plus 4 equals, and then on the right side of the equation, the number has become 12. Now, subtract 4, and bye-bye 4's, x equals 8. Done. Kind of cool. This is less work than the distributive property, but it does require you to notice something a little bit more. So, you might not decide this is your method, but if you want to be lazy and smart, this is the method for you. Moving forward, we have example 4. Now, this one's a little bit extra tricky, so I'm going to start by, rewriting the equation just to feel like I'm in control here. The trick here is that something's got to distribute with that x minus 2. And it's not 7, actually, it's negative 7. That's why I kind of underlined that part. So it's negative 7 times x, and negative 7 times negative 2. So we have 4x minus 7x. That's not terribly exciting. At the end, it's plus 14, because negative 7 times negative 2. And it equals 26. Now we can go ahead and combine the like terms. We have 4x minus 7x. That's negative 3x. Still have that plus 14. Still equal to 26. If you subtract 14 from each side, then you can go bye-bye to the 14s. And negative 3x equals 12. Okay, divide each side by -3. Finish up, say goodbye to the 3's, the -3's, and x equals -4. All right, it's getting fun. We have one more good just equation example. Here we have -3x minus, and then in parentheses, x minus 2 equals 15. Okay, so here the trick is figuring out what the heck is in front of the parentheses. And if there's nothing written there, it means there's a 1. So we're going to actually multiply -1 by x and -1 by -2. 3x minus x, or minus 1x, plus 2 equals 15. Pay attention to those minus signs and how when you multiply the two negatives it becomes positive. It's all tricky details. All right, combining like terms, -3x minus 1x is -4x. Now we can subtract 2 from each side. Bye-bye 2's. -4x equals 13. Divide each side by -4. And x equals -13/4, which is like -3 and 3.25, or -3 and 1/4. Again, improper fraction really is the best. Decimal is fine. Mixed number, if you really want. Okay. But again, all three of those are correct, so any one of them is acceptable, and that's true. Last example, we've got a story problem. Here we have a dude named B.I. His parents almost got his name right. If they just moved one letter up on the alphabet, could have been C.J., but oh well. B.I. commutes to work every day on subway. During the trip, he purchases a newspaper for $1.50 every day and leaves a small tip for the newsie. Funny story, newsies actually exist in large cities. They are not just a creation of Disney's imagination. He leaves the same tip every day. During a 5-day work week, he spends a total of $9.25. How much did B.I. leave for a tip each day? Okay, so first order business, you have to define a relevant variable. Trying to figure out what the variable should be, this is really tricky for a lot of people. Often the answer to that is in the actual question. How much did he leave for a tip each day? Well, there we go. We'll make that our variable. T could be the amount of tip each day. And we should use the units, so we should say in dollars. Amount of tip each day in dollars. That's the variable. Now the equation writing isn't necessarily easy, so let's go bit by bit. It says he purchases a newspaper for $1.50 every day and leaves a small tip for the newsie. So that's $1.50 plus T, because $1.50 plus the tip. During a 5-day work week, he spends a total of $9.25. So that means he does this $1.50 plus T 5 times, so it's multiplied by 5. And the total is $9.25. Now we have an equation we can work with. So I'm going to rewrite it so it's all chromatically correct in the same color. Now, 5 can go ahead and multiply to distribute. 5 times $1.50 is $7.50. 5 times T is, 5T. So $7.50 plus 5T equals $9.25. We're solving. We're subtracting 7.5 from each side. Goodbye to the 7.5s. 5T equals 1.75. If you divide each side by 5, then goodbye to the 5s, and T equals 0.35. There we have it. Well, almost. We should actually write the answer. B.I. leaves a tip of 35 cents each day. So B.I. leaves $0.35 or 35 cents each day as a tip. And that is our answer. Hey, thank you for watching. Please let me know if you have any questions, either in the comments or through an email. And thanks again for watching.